Even with the help of AI, the reason why so many legacy modernization programs aren't really taking off is because they lack the harness. They lack the harness that will leverage the AI in the right way to prove behavioral equivalence of the modern system and make sure that the modern system has the parity with the legacy system, which is critical to make sure that there is no operational and reputational risk as a result of the legacy modernization. So let's play this scenario out. Let's just say there is an enterprise that has a COBOL code base, which is about 2.5 million lines of code. And let's just say that each COBOL file has about 4,000 lines of code, which means it's about 625 large COBOL files that need to be modernized. Now, let's just say we have 25 developers working on modernizing this code base with the help of AI. So each developer will now have 25 large files that they need to transform from the COBOL code base to, let's just say, a Java code base. Now, how can they go about this? So one approach in terms of how they can go about this is that they could open up their favorite IDE, launch, just say, a copilot, and select the language model of their choice, pick the COBOL file to translate, take a chunk of that code and start to translate it using prompts. So they start doing that, then they start to realize that, you know what, this particular block of code is dependent on other blocks of code. So they bring some of that context into their prompts. And then they realize that, you know what, some of this code is dependent on code in other files outside this environment. So they bring that as well. And then they realize that, okay, you know what, I'm lacking business knowledge to validate what the AI is going to do. And the AI also needs some of the business context. So they go ahead, dig up the documents and bring that into the context. And then they realize that, you know what, the code base that we are going to be building has to follow certain standards and guidelines and talk to microservices a certain way and so on. So they go ahead and incorporate some of those. So they do that and then they negotiate back and forth with the AI and then they finally generate for that particular COBOL block, let's say they generate a Java microservices block of code. Now they need to do that for all the different blocks of code in that 4,000 line file. And then they need to do that for, let's just say, for all of their 25 files. Now, while they are doing this, right, all of these other developers are doing the same thing with all of their files as well. But so when all is said and done, guess what is going to happen? You're going to be left with a Frankenstein code base. And the reason for that is going to be three things. The first is that everybody prompts differently, and that influences how AI generates the output. Second is that they'll give different contexts to the AI, and that will definitely change what the AI produces. The third is that they all come in with a different understanding of the business domain, and that will influence how they prompt and how they validate what the AI does. And then lastly, right, the non-functional requirements, things like monitoring, observability, performance, they may have a different understanding of it at a lower level of detail. So they'll prompt the AI based on that, and that will result in a particular output. So now you're ending up with a number of different islands of different patterns and different styles and different consistency and quality of the code that has been produced. So instead of actually reducing the risk of doing the legacy modernization using AI, you're actually increasing the risk, because guess what? AI is producing a lot of code. It is producing a lot of code that is not humanly possible to review in a short span of time. And when all of this code comes together, it all comes to a head, and now you have a big mess to resolve. So what is the solution to this problem? And the solution to this problem is to have a harness for legacy modernization. What a harness is going to do, it's going to streamline, it's going to orchestrate, it's going to organize the entire end-to-end life cycle of legacy modernization. And by having this harness, all the developers, the team working with the AI is following the harness, and that is driving a lot of the consistency, a lot of the quality, and ensuring that behavioral equivalence is ultimately realized. So what are the components of a harness? I would say there's four layers that you need to look for in a harness for legacy modernization. The first layer is to actually have pre-built agents that do a lot of the heavy lifting. So think about, like, one of the steps for legacy modernization will be code to spec, taking the code, converting that do business specifications, reverse engineering it. That will have a series of steps and actions and skills that are needed to do that. All of that is included in an agent. So similarly, you will have agents like this that are pre-built, and that will drive a lot of consistency into the end-to-end modernization process. And the other thing it will do is that because now all these agents are pre-built, any tweaks, any changes that need to happen in terms of the corrections to be made to the prompts or the context can happen in those pre-built agents, and those will be leveraged by all the developers, and they can all work and get the benefit of all of those improvements. So that is the first win. The second one is having a very visual way to orchestrate all of these agents together. Because if these skills and links and decision points are all buried inside code, it is going to be hard to bring to the surface what is significant and what matters and how everything works together. So having a very visual way to orchestrate all the agents is going to help drive and improve that level of consistency. The third aspect of this is going to be having the right frameworks. Let's just say, for example, if file number one has been modernized and file number three is now being modernized, the context from the file number one needs to be brought into file number three. And that information is stored as part of the memory. And you need long-term memory because a lot of these large code bases require several steps, and we need the agent to remember through all of those steps. The other thing is having the right level of context compression. So too much context is going to reduce the relevance of the output. Too little context is going to lead to hallucinations. So how do you compact the right level of context density to have the maximum realization of the accurate output coming out of the generation? So all of that is managed as part of this foundational framework layer. And then finally, underneath everything, you need to have a context graph. The context graph connects all the pieces together. So it's not just the code that you're modernizing based off, but you need reference documentation from a business domain, business knowledge perspective. You need the standards of the enterprise in terms of how code needs to be written, how architectures need to be formed. You need to have a certain set of guardrails. All of these things need to come together as part of a context graph, which is kind of, the next level to the RAG. So RAG is going to be more of finding similarities in the context, but the context graph will relate all the different pieces that need to come together to form the right context to be given to the AI. So these four layers all together forming the harness is going to drive the quality and drive the speed of legacy modernization and enable that project to be successful. So if you have questions about this, please feel to reach out to me and we can have a good brainstorming discussion. Thank you.